So is Aditi going to join or do we need to wait for her? Do you have any idea, girls? No idea? Okay. Are we ready? Yes, are you done? Done with the recap? Okay. So first, question for Adya. Give me the examples for the logic gates. Some names of logic gates. We studied about four logic gates and or so. Okay. Okay, that's correct. And or not and yeah, now which gate it is? Yes, it's XOR gate, right? Now yes, Adya, which gate does it represents? And gate. Yes, which gate it is? Not gate. Okay, so these are the basic gates which we required. Okay, now first combination. So first combination I given to you is not A and B. Okay, the combination is P is equals to not A and B. So see, remember some fundamentals law is first you need to solve the brackets. Okay, whatever the thing is in a bracket, you need to carry out this bracket things when there is a NOT gate. So here you can see in the bracket it's A and B, and A and B, and the output P is not A and B. So first you need to create a logic gate for a combination of A and B, and then you have to consider the NOT afterwards. So first solve this part, the bracket. Okay, so let's create a gate. Obviously this is already there. So okay, so this is A and B, and the output is P. No, our output is not P, right? We have to write not AB. So the resultant of NOT gate, resultant of A and B and the NOT gate. So here we can write it like this. This is, and the answer now is A and B. This is A and B, and this will result into P is equals to not A and B. So the resultant of A and B will get to the NOT, and NOT will inverse the result, and that will be the value for a P. Okay, so as per that, here we have AB, but here we need to mention a single output because there is nothing here for notation. So specify some notation over here. Which symbol I can use over here for notification? For here, any one character to represent this path. As we already discussed, then when you need to consider the inputs, you can begin with A, B, C, D, and when you are considering the outputs, you need to consider P, Q, R, S, something like that. Okay, so here this is input. No, this is output from A, B, right? So we can give a name like R, okay, which resembles the output. So here uh, result, R stands for result, we can consider like A, B, and resultant is R, and R will be input for P, the NOT gate, and P will be as out. Okay, so this is a combination of two gates, AND gate and the NOT gate. Now let us create the truth table for this particular gate. Okay, first for input, first input is A, second input is B, then third here input will be R. A and B will be R, and then not B. So here first you have to consider input A, then you consider input B. Now for R, you can represent R in such a way like R is equals to A and B. Okay, you can easily represent this such a way R is equals to A and B, and R is an input for P, so this will be considered as input for P. So you can say not P is equals to not R, or instead of that you can also say not A and B. Got this? Any doubt about this headings? First input A, second input B, and then here comes with the R. R is A and B, or I can say P is equals to not R, or I can simply say not A and B. Clear? Both of you? Now let's fill the data in it. A, B. If A is 0, B is 0, in this condition R as A and B also going to be 0, and as P is equals to not R, it will inverse the value of 0 to the 1. So now 0 will change to 1. Next, another option, 0 1. A is 0, B is 1. In this turn also A and B will result into 0, and this time also R will result into 1, or P will result into 1. Again 1 here, 0 here. In this also resultant will be 0, and not resultant R will be equals to P. 0 will turn to, here again 1 1. In this case 1 1 true true will answer into true, and the resultant will be, okay. So this is a true table for this particular logic, this combination of steps. If you got this or any doubt, just here, and how to represent them symbolically. So note down this. Second combination I will give you, and you have to fill the true table and have your reaction when you down this. Yes, yeah, completed. So let's have the another example. Okay, so make sure, make a proper circuit, use scale, pencil to draw circuits. Also use a scale, make a proper circuits, don't have a rough work over there, and also make a proper table. If you don't create a lines over here, you can simply write the data in a sequence, don't need to create a whole table structure, it's okay, but make sure you consider all the inputs and all the outputs and the conditions. Okay, so here A and B are the only two inputs here. A and B are the only two inputs over here, so we have 4 lines over here, 1 2 3 4 lines. So here you can see it's like a 2 to the power n. Here n is a number of input. Okay, you can check out how many rows you need to create, how many rows you need to create for a table. You can simply use this formula 2 to the power n. As you know, 2 is a binary number, right? 2 stands for binary base. So if you have 2 inputs, the probable rows is 2 to the power 2, which is 4. If you have 3 inputs, 2 to the power 3, which is 8. So if you have 3 inputs, you need to create the 8 such lines. Did you got that? 2 to the power n. This is a formula, and here n stands for input. inputs. Okay, and this will generate a number of rows. Let me write it in a proper way. Remember this. Let's try the next one. Okay, create this. Create the circuit by your own and show me on the cameras when it is done. It's not A or B. For example, okay, okay. I'll make it. It's C. Just think about it. You don't need a brackets over here, right? The reason is, just think about the OR gate. OR gates require how many inputs? 2. OR gates requires 2 input. So here, you can simply say here, uh, for OR, first is this and second one is this. We can say not A or B. Okay. Actually, I use a space as an indicator. You can also use a bracket and space, both you can use. Okay. So as a space, I separated A and space OR and a space B. Bracket is also good. When done, show me on the camera. Okay. First, show me the circuit only, then begin with the table. It's okay. Adya, your is perfect, and Yana needs to have a bit change. Okay, Adya, you're done. Uh, Yana, in the second gate here for OR, you have to consider 2 inputs. So you have to make a 2 input symbols, not a single one. Okay, I'm making it. Just check this out. First is not A. Here is A, not gate. Then OR B. So as an input for the OR gate and the second input. So you can consider it. Yes. Got this? You made a correct diagram. Just you need to have these 2 inputs like this. Okay, how many row did I need to generate over here for a table? 1 2 3 4 5. Okay, I made one extra. Perfect. Hey. Okay, so Adya, which need to fill over which data will be here first block? A. Okay. Then here not A, that's good. Not A, or you can simply say R is equals to not A. Okay, then here P, and here P is equals to R or P. Okay, good. Or either you can simply write the whole statement. Okay, good. Yeah, now tell me the answer for this. A 0 here, 1. In the beginning B also we consider 0. Now the answer 1. Okay. A as 1, 0. In the beginning 0, this also we consider 0. Okay. Okay. This time once this is 0, then 1, then this will be 1 0, and there will be 1 1. Okay, the resultant is 0. Okay, so here 1 0, we take it 1 1 1 1 0 1, we take it 0, it becomes 1, take it again 1, and it becomes 1. So combination is like 0 0 1 0 1 1 0 1. Okay, so all the possible results we considered. Having any doubt, just let me know. Okay, there is no issue about the sequence. Okay, if you put this row over here on a second row, either you can write the last row first. There is no issue with that. Okay, so don't worry about it. If your sequence is not matching, just find out all the sequenced matched, like 0 1 0 1 1 0 0 0 1 0 1 1 and 0 1 1 1. Just check out your answers. Is there any mismatch? No? Good. Okay, can I make it a bit more difficult? Let's add one more gate. Okay, right now we are working on 2 gates, the 2 combination. We are going to increase one more gate. Now this time we are going to have 3 gates at a time in a circuit. So try this one. clear? So show me done. I'm working on it. Okay, make it. Camera. Show me the camera. A B. Okay, that's perfect. Good, good. A B. So, Adya, how many rows did you create it for the table? How many rows did you create it for the table? 5 columns? Rows. I'm asking about rows. And Yana, what about you? How many rows did you create it? 8. Yeah, that's perfect. Adya, need to make a 8 rows. It's 2 to the power 3. We have 3 inputs over here. So 2 to the power 3, we have 8 rows. Okay, we must have that. Reduced. This is for R and towards Perfect. Number of columns, it's 5. You both have 5 columns, or more than me or lesser than me? Columns. How many columns did you create, Radhya and Yana? Did C? Check. A, B are for A and B, so we're gonna have R as well over here. Now not R as a Q and Q or C as a P. So this is P as Q or C. No, not. You can simply write as per AB with respect to AB also write. Okay, you can also write here not AB, or here A and B. Sorry, A and B. Okay, here you can also write not A and B. And also here you can write the whole statement as P is equals to not A and B and the whole statement. Okay, let's fill the data. A as a 0, B as a 0, A and B will be 0, not A and B will be 1, and the P will be A or C. So I need one more input. Yes, you require one more input. Here we require a C. Yes, you require 6 inputs, 6 columns. A and B, which is 1, and C, this or this. P is equals to the whole statement. Okay, so in the beginning A0, B0 and C as well 0. Okay, so the resultant will be here this or this. Okay, this is having, I am having small column over here, so for just now I am writing here like this is our Q and this is C, so I am just writing Q or C. Okay, you have to write the whole statement over here. I just for I am having small column, so I have mentioned Q or C. You have to write the whole statement over here. So as for me, A0 10, which is 1. Now 1. Okay, and as per that, 0 0 will be 0, 0 1 will be again. Here also 0, here also 0, 0 0. Oh, here we have 1 1. Now not 80, so this becomes 1, this becomes 1, this becomes 1. I'm speaking, yeah. Okay, just check out. Is it perfectly matched? I was just murmuring, so okay, don't try to match my table. Okay, do it your own way. And if you then find any difference in my table and your table, just let me know. We'll check out whether your table is incorrect or whether mine. Okay, so 0. Let me verify one more time. 0 0. This probability 0 0 0 0 0 1 0 1 1 0. All probable coincidences created 0 1 0 1 0. 100% true. Difficulties? Yes. What problem? Those are there. Let me know. What's the issue? Do you find any difficulty in creating this table? Okay. Yes. Okay, good. So make sure the formula I already told you 2 to the power and use that so you can get a whole probable rows. You can see no repetition is there here. Okay, no repetition is there. Any single statement is not repeated. You can see 0 0 0 0 0 1 1 0 1 0. Every combination is different. Okay, must be included. query? Yes, Yana, any query? Okay, show me your table if you have created. Did you fill the data? Okay, just a sequential data. It's okay. Just show it to me if it is. Um, just so completed. Yes, Adya. Did you get the same results? Okay, so try to match the combination. If you have any mismatch in any single row, also just let me know. Okay, if you find it. Then okay. Uh I am giving some homework. Better I can give it in form of DPPs. Okay, I will give it. I am having one printed page from the textbook. Okay, first you will solve that examples, and then I will give some more examples by myself in the next lecture. So as a DPP, I will send you a one like picture like thing. In that you will get all the gates. You need to try with the basic ones first, and then we have a complicated some circuits in a next lecture. Okay, in the beginning I will ask you some circuits and you need to solve that. Yeah, they left it. Check out the table. Okay, show me your table if you have created once. Okay. Okay. Okay, good, good. Not an issue. See, one of the best ways to feel this data is, see, how many inputs do we require? How many? Three. So 2 to the power n will be 2 to the power 3 will be your 8. Okay. In the 8 we have a probable values. We have 8 value. So we can divide this 8 row first 4 and the second 4. First 4 combinations 0 zeros and second inputs all combination first ones. 0 sequence and then 1 sequence. In this second here, break it down in sequence of 2 twos. Okay, first 4 4 sequence, then 2 2 sequence, then single single sequence. Here the combination of twos 0 zeros, 1 ones, 0 zeros, 1 ones. Okay, and here 0 1 0 1 0 1. Got this? divide the sequences, break it down. So here we have 8 divided by 2, 4 zeros, 4 ones. Then break them and 0 0 1 1, 0 0 1 1. And now break this 0 1 0 1 0 1 0 1. Here. Okay, so easy to crack this. Okay, so this will cover all the probable results, and this covers all. So keeping it over here for today. We'll see in the next lecture for next circuits. Okay, thank you, welcome.